Hello everyone, I welcome you all to this session today, wherein we'll be discussing a question from the algebra part, right? Modulus part. Right? So let's get started with the question, right? And just to let you know, all right, so that you can make use of this channel better. So on this channel we are uploading questions on regular basis. So questions, not just questions actually, we have two types of videos in this series. If you'll watch all the videos that we have, one type of video is wherein we deal with concepts also, followed by a few question discussions. Second is the type of video wherein we take up questions of particularly CAT level difficulty. This is one such video, right, wherein we'll be discussing the question. So I'll just show you the question here. So you can just pause the video, try out this question, see which option choice matches with your answer, and then resume watching the video whether your approach is the correct approach or not. So I, however, here in the video will be discussing the question right away. So let's get started. So the question is, find the sum of the roots of the equation. So this is the equation that we have. So I'll just write down the equation. Mod of x square 7x plus 13 is equal to 4x plus 1. So I need to get rid of this mod, right? So the way to get rid of this mod is to check when is this value inside the mod positive and for what values is it negative. Now if you pay close attention to the expression inside x square minus 7x plus 13, please notice for x square minus 7x plus 13, can we not write it as x minus 7 by 2? The whole square, please notice, x minus 7 by 2 whole square, expand, what do you get? We'll get x square minus 7x plus 7 by 2 whole square. Now what I will left with? 13 minus 7 by 2 the whole square. So this will be what? X minus 7 by 2 whole square plus 13 minus, this is 49 by 4, which is nothing but x minus 7 by 2 whole square. 4 into 13 is 52, 52 minus 49 is 3 by 4. Now if you notice this expression here, can I say is always positive? Because it's a real number square which is never negative plus some positive value. So that means, can I say x square minus 7x plus 13, this value is always positive, always greater than 0. Now one more way in which we could say this is positive always is, please notice the discriminant of this particular quadratic. So if you look at the discriminant b square minus 4ac, this turns out to be negative. So if discriminant is negative, that means when you try to plot this particular curve on xy axis, it is never going to intersect the x axis. So that means it's either entirely going to be above or below x axis. Look at the coefficient of x square, it's positive. If coefficient of x square is positive, it's always an opening upward parabola. So thus it's always going to be like this, the given expressions graph. So y equal to x square minus 7x plus 13 will be like this. It's always above x axis, that means always positive. The second way of saying that the given expression is always positive. Method 1, method 2. Now if I continue, so the moment I know x square minus 7x plus 13 is always positive, can I say the left hand side will be mod of some positive number. So mod of 3 is simply 3. So this will also become x square minus 7x plus 13 equal to 4x plus 1. This will be x square, let's bring all terms on one side. 7x minus 4x is 11x, 13 minus 1 is 12. So we can factorize this as what? This will be 4 and 3, no, right? So that's it. This is a quadratic equation now, quadratic equation. So if you want, we can find the roots also, not by factorization but by using the formula minus b plus or minus root over b square minus 4ac by 2a. That's the formula, right? But what is he asking us? Sum of the roots. So how do we find sum of the roots of a quadratic equation now? We have a direct formula. So sum of the roots is nothing but minus b by a. For ax square plus bx plus c equal to 0 type of equation, sum of the roots is minus b by a. What is b? Minus 11. What is a? It's 1. So minus of minus is plus, 11 by 1 is 11. So my answer is going to be option choice A over here. Alright. So find the sum of the roots, we'll say the answer should be 11. So this mod has no impact because the term inside the modulus is always positive. I hope we are clear with this. Okay. There is one more thought that the students might have. Okay, for getting rid of the mod, why don't we square it on both sides? Now squaring on both sides might bring in some extra roots. So that means after you square it, after you simplify it, again that's a very difficult process in itself, but again after that whatever roots that you get, there might be some extra roots. So thus squaring and simplifying is not really a good approach, right? So the better way to simplify this modulus would be this: look at the term inside the modulus, when is it positive, when is it negative, and accordingly break the intervals, right? Divide the entire minus infinity to plus infinity into those intervals. Alright, so with this we have come to the end of the session. Thank you and all the very best.